All right, so question 7. Before I get into my solution, I want to point out that there are going to be lots of possible solutions for these. Um, Yours might not look exactly like mine or anybody else's, and that could be fine. So we have some conditions that we have to meet. Um, Other than that, we have a lot of freedom around what these functions look like. So let's just go bullet by bullet. So we are told that f of -2 is 2. So that means that basically they're telling us that this point right here, f of -2, 2, sorry, -2, 2, exists on our graph. We are also told something about the limit there. So we know the limit as x approaches -2 of the function is 1. So what does that mean? That means as our function approaches both from the left and the right, and I want to make sure I don't encroach on what's happening with -1. As we approach from the left and right, we're approaching +1. So I believe now I have handled the first bullet. So I have a point, I have the point -2, 2, and I also am showing that the limit around x equals -2, or the limit of this function as x approaches -2 is +1, which is why I have that basically the graph converging at this open circle here. One more note, why do I have an open circle there? Well, remember that for a function, what makes a function is that for every point in the domain of the function, you get exactly one output. So for every x value, I get exactly one y value. Since I've already said that when x equals -2, y equals +2, I can't also have y equal 1. So I have to show that there's a hole here. All right, so that's the first bullet. The second bullet is somewhat similar. I am told that -1, +3 is a point. I am also told that the limit exists there, and the limit's also equal to 3. So what am I going to have here? So kind of made things awkward for myself, but that's okay. I'm going to have a very steep increase. And I think in this case, as I've said in other videos, you've probably seen other teachers and other things I've posted say this. The limit of a function at a point and what the function actually is valued at that point aren't necessarily the same thing, but in this case they are. So I think the second bullet I have now dealt with. So let's move on to the third. F of 1 is not defined, but the limit as x approaches 1 of f of x is 0. So because I know what the limit is, as x approaches 1, the limit is 0. I'm going to have an open circle on the x-axis here. And part of the reason it's an open circle is because I know this function is not defined here. So because of that, I'm going to have my graph approach this point from the left and from the right. Again, why am I doing this from the top left to the bottom right? It's really, you have a lot of choice here. It does not say what's going on far away from these points. So this is your solution, again, might not look like this. But here I think I have the limit existing at x equals, or the limit existing at x equals 1, that limit being equal to 0, but 1 is not in the domain of this function. So, for example, I don't want to have a closed circle, anywhere else at x equals 1. So I believe that handles the third bullet. So now, what do I do with the last one? I know that f of 2 equals 1. So that's a point that exists here. And I also know that the limit does not exist. So there are lots of ways that the limit might not exist. I'm going to show you one, and I'll talk about the others. So one way that the limit might not exist is if maybe the limit exists from the left and it exists from the right. But clearly these limits don't agree with each other. So let's give myself some more detail here. I believe the limit as x approaches 2 from the right of f of x is 1. I also believe that the limit as x approaches 2 from the left of f of x is, of course, I didn't put it in a whole number, but that's okay. Let's say negative 0.6. So the limit from the right exists. The limit from the left exists. They do not equal each other. So what does that mean about the limit as x approaches 2? That does not exist. So you could also have like a vertical asymptote, or maybe the function is just, actually, those are probably the two most common ways to have a limit that fails to exist. But again, this is one solution. Yours might look very different, but it also might meet these conditions here. So let's go ahead and move on to question, or part B of the question. So same kind of thing. I have some conditions to meet. So the first bullet dictates a bunch of points. So let's fill in those points. G of negative 2 is positive 3. So there you go. G of negative 1 is negative 1. G of 1 is negative 2. And G of 2 is 3. So that should be simple enough. All I needed to do there was to respect or basically plot those points on this graph. I have no idea what's going around them yet, but for the first bullet, I just need to plot those points. All right. Now at x equals negative 2, negative 1, 1, and 2, G has a limit. And its limit equals the value of the function at a point. So basically, what does that mean? It means that around these points, what happened to my last point? Let's put it back. So basically, around these points, I know that the function, and again, I know that the limit of the function equals the value of the function at those points. As for why I'm drawing the curves in the directions I am, you have a lot of choice there. But what really matters is the fact that I am now just having those curves drawn through there shows that as x gets near negative 2, for example, y gets near 3. And I also know that that point, negative 2, 3, is on this graph. So now I think the first two bullets are taken care of. What does the last one say to do? G of 0 is not defined, and the limit as x approaches 0 of g of x does not exist. So let's go ahead and connect these. So it says the limit does not exist as x approaches 0. So I think I just did a jump continuity or jump discontinuity. So let's try to do the same thing here. I really wish I knew how to erase these. Okay, so let's scribble this out and do this instead. Instead of having a jump discontinuity, I'm going to do a vertical asymptote. Let's say that as x approaches 0, this gets, y values go higher and higher and higher. And then maybe I get the opposite behavior from the other side. Or really, let's go ahead and mix and match. Maybe from the right-hand side, I have a jump like this. So let's make sure we believe that I have respected this last requirement here. G of 0 is not defined. I have tried to make clear on my graph that when x equals 0, there is no y value that corresponds to it. And the limit does not exist. Well, what happens as I approach from the left? Looks like y goes to infinity. As I approach from the right, it looks like, again, y gets closer and closer to like negative a half or negative 0.6. Those things don't agree. So that means my limit doesn't exist. Last thing I'll do here is Go ahead and connect these. And again, your graph could look quite a bit different from mine. But I do believe that I have handled all of these requirements.